Okay, fifth graders, today is Wednesday, October 9th, and we are continuing on in Module 2, Lesson 5. And today we're going to go back to revisit the idea of area models. And we're going to use area models today to help us multiply numbers. And I want to show you how the area model is just a picture that shows the distributive property. Okay, but first let's talk about the problem of the day. As we know, we can use an area model to help us multiply. Okay, area models are just drawing a rectangle and then finding the area of that rectangle, because as we know, in order to find the area of this rectangle right here, excuse me, we have to multiply the length times the width, right? What's the length? 23. What's the width? 31. But I've split up 31 into two parts. The tens part, which is 30, and the ones part, which is 1. And I basically split it so that there are two different rectangles now. Do you guys see that? Okay. So do you guys agree that the whole rectangle is 23 times 31, the area of the whole rectangle? Yeah. But what I did is I split it up so that it's easier for me to do. How do I find the area of this blue rectangle, the top part? I have to find the length times the width. What's the length? 23. Oops. What's the width?
1.
So what's 23 times 1?
23.
What's the area of that part? 23. Good. How do I find the area of the green part down below? I have to do 23 times 30. I can do that in my head, sort of, because I know that 23 times 3 is 69. So what's 23 times 30? 690. So if I know that the area of the blue part, the top part, is 23, and the area of the green part is 690, how do I find the area of the entire, rectangle? Yeah, I have to add the two partial parts, right? I have to do 23 plus 690. When I do that, I get 713. So the entire area of the entire rectangle, 23 times 31, is 713. We also know that we could use standard algorithm to do this, huh? We could do 23 times 31 using the standard algorithm. When I do the standard algorithm, I have to do 3 times 1 first, which is 3. 3 times 2, which is
2.
Then I put a placeholder 0. How come? Because my next is not really 3, it's 30, right? So then I do 3 times 3, which is, okay, and then I do 3 times 2, which is
6.
Okay, and then I have two partial products and I know that I have to add them up, right? Okay, so let's see. The directions tell us to draw an area model and then use arrows to match the partial products from our area model to the partial products in the algorithm. What I notice here is I have 23. That's one partial product. I can draw an arrow to show that, hey, there's 23 too in my standard algorithm. And then 690 was my area of my second rectangle. And there's 690 in my area in my standard algorithm too. And then of course when I added them up, I got the same answer for my total product. Through this, we can see that every part of the area model is also in the standard algorithm. Do you guys see that? Okay. This only works, by the way, or this works best if we put the first factor on top of as the first factor of our standard algorithm too, and then also if we put it across. Okay? I'll show you why in just a second. How come they don't match up? This time, instead of putting 23 at the top, I put it here. Is that okay? It's like I just took the rectangle and went like this, right? Or like this, right? Can I turn it? It's still the rectangle, same rectangle, no matter how I turn it? Okay. Now, if I do that, I can still split the rectangle into two parts. Instead of saying 23, what could I call the bottom part? 20, right? And the top part would be? How would I find the area of this part here?
31.
Which is?
93.
Okay. And then the bottom part here would be 20 times 31, which is 620. And then if I find the entire area, I would have to do 93 plus 620, which is still 713. So same area because it's the same rectangle. But if I did my standard algorithm like this, Am I seeing the same parts?
No.
Where's my partial products? Where's my 93? Where's my 620? How come they don't match up over here anymore like they did? Turn and talk to someone. What happened?